Yeah, that may seem big, but numbers can get an awful lot bigger than that. You could have 10 to the power sort of 10 to the power of, I don't know what's that, a billion? You could 10 to the power of a billion, you could 10 to the power of a trillion, you could 10 to the power of 10 to the power of 100 to the power of 1,000 to the power of a million to the power of a billion to the power of a trillion. They just go on forever. This is why that's a tiny number compared to these, but even these are tiny. That's why we use the symbol infinity. Because if you have sort of an infinite number of, you have a million zeros after this or something, they just become astronomically huge. So I don't think anything exists in nature that's as massive as this. Unless you're going to start counting all the quarks and gluons and electrons, I suppose, but or unless you start adding up the total volume of space, and I suppose if you add up its total volume in terms of cubic millimeters, or maybe cubic centimeters, I suppose it would come out probably about a bit like this, but even bigger. But nobody uses measurement units like that. So anyway, that's all I wanted to say.